first of all, what is the derivative? What are we talking about? We're talking about slopes of tangent lines at specific points. That's the big idea of what's going on. If we can find a derivative, that gives us the equation to find any slope of any tangent at any point. And we're about to learn the power rule that makes things faster. So, let's say we used our definition of the derivative, and we did the derivative for x squared, and we found it was equal to 2x. So we're going to take away the 5 minutes and say, pretend we did it and got that answer. And then we feel like, oh, good job us. Okay? And then we looked at x cubed, and we found the derivative to be 3x squared. And we did the x cubed. Remember how annoying it was to do Pascal's triangle with x plus h, x plus h, x plus h? And then I said, oh, let's do x to the 4. That would be x plus h, x plus h, x plus h, x plus h. And we get our derivative to be 4x cubed. And we start looking for a pattern. Right? If I had added x to the 5, any guesses what the derivative would be? Are you noticing a pattern? X squared was 2x. X cubed was 3x squared. X to the 4 was 4x cubed. What do you think x to the 5 will be? 5x to the 4. Was it hard? No. Is it a lot faster than the definition? Right? Can you imagine if you had to do the definition, you would have to go down Pascal's triangle until you had 76 items to expand x plus h to the 75. Write out all 76 of them. Cancel things out. Factor an h out of 73 of them. Cancel out your h's. Have everything go to 0, only to find out that the derivative would be 75x to the 74. And this is our first shortcut, which shaves off a lot of time. Right? I think in this one, doing the x to 75, I think this would take at least 15 to 20 minutes to write it out. And lots of paper. This is the power rule. If you have a power, then the exponent can come out in front, and you can subtract 1 from the exponent. And not only does it work with nice numbers, it also works with fractions. So check it out. Ooh, can I do? First of all, I'm going to add a little bit to the power rule. Okay? If you had 5x squared, the derivative, well, this says if you have a power, the number comes out in front, but I have a 5 out in front. What do you think I did? If I had 7x cubed, my derivative would be, well, power rule says the number comes out in front. Subtract 1 from the exponent. Can you see what's happening? But the powerful thing about this is it says it works for all rational numbers. That means fractions, everything. Remember the question we just did? So I said this is now going to take 4 seconds, because it's going to take you 2 seconds to write this. And then it's going to take you 2 seconds to bring that half out in front and subtract 1 from the exponent. And we just used the power rule to save like a ton of time. Plus, you don't have to remember that difference of squares and conjugate that you'll probably forget when I ask that same question on a quiz. I'm like, oh, I forgot this, but I know the shortcut. Super powerful, super fast to find the derivative. One thing that you will get really, really, really good at with derivatives, especially the power rule, is subtracting 1. Like, you have to subtract 1 with numbers, with fractions, with negative numbers, with negative fractions. You're going to get really good at subtracting by 1. But, oh, I'm glad I'm taking calculus. I'm really brushing up on my subtracting 1 skills. So, like, the thing about calculus is it's actually not that hard. Some of the stuff is not hard at all, but when you do it, if someone doesn't know what's happening, it looks crazy impressive. But it's not that hard. It's sort of like, people look at it like, ooh, that looks scary, and you're like to yourself, actually, it's not that bad. But someone who doesn't know calculus, you never tell them it's actually not that bad. You're like, oh yeah, it's hard. You shouldn't do it. Don't try this. Okay? So, x to the 7. Should I give you a 3-second head start? All right, how did you do? See how I said this is like grade 9? You can just like write the answer. When have you done a math question where you just like can write the answer? 3-second head start. All right. You can use any notation that you want. Often, if you have y equals, you'll either write y prime, or if you have y equals, you'll write dy dx. But you see how the last question had f of x equals, you'd probably write f prime of x. Good luck in your game. This one is a 4-second question. The power rule only works if you have a single power. This one has the x cubed though on the bottom. So we have to take an extra step to write it as a single power using our negative exponent rule. Once we've done that, we can now find the derivative. The -3 would come out in front. And again, you'll get really good at subtracting. -3 minus 1 is -4. Did you write -2? Yes. And this one, I've already given a hint away. This is another 4-second question. You would take the time first to change it to x to the half. For this one, I would probably change to regular function notation with the derivative. Bring the half in front, subtract 1, get 1/2 x to the -1/2. This is like a 6-second question. We would first have to say that's x to the 4/3, because the cube root is a third. Then take another 2 seconds to use your negative exponent rule to get it to be a power. And now I can bring out the -4/3. Again, get really good at subtracting 1, which is like subtracting 3/3. And I get -4/3 x to the -7/3. Okay? Was it that hard? No. Does it look impressive when you start with this and almost instantaneously write this for your friend and they're like, where'd the 7 come from? What's, like, if you didn't know the rules, it can be very confusing to look at what happened. But if we know the rules, then calculus is straightforward and relatively few steps and we've got the answer. So, here, we've done this already. You have to change things to exponents in order to use the power rule. And what's going to happen in calculus is we are going to keep adding rules for different situations we run into, so that we don't have to go back to the definition and try to solve it with the definition. And rule number 2 I already showed you. Is if you have that number in front, that number just stays in front. When the exponent comes out, it just multiplies by that number in front. So in our first example here, the derivative, I bring the 7 out in front. 7 times 4 is 28. Subtract 1 from the exponent. Did I skip something? Did I go too fast? Maybe. Was there stuff? Oh, did you have things to write on this one?
Yeah.
Oh, I thought it was printed. I'm sorry. Please let me know if I I have a set of notes that's filled in, and on those notes, whatever you have to write down, I have orange boxes which I click, which reminds me you have to write that down. But this is too much fun to have the answers already done, so I like it better if it's blank, because then I get to do the derivatives too. Okay. Bring the 5 out in front. Negative 2 times 5, negative 10. Okay. The last one, you have to do some preliminary work. Can you see that that cube root would be x to the 2/3? Now, when we move the power, the 2/3 is just the x. Can you see that that 2/3 is not to the 3? So when I move that to the top, to make it negative 2/3, the 3 would still be on the bottom. And now when I find the derivative, negative 2/3 would come out in front. Well, how do I multiply fractions? Multiply the tops, multiply the bottoms, subtract 1 from the exponent, and you get negative 14 over 9 x to the negative 5/3. In perspective, do you know how annoying this would be with the x plus h? You would actually have to know a difference of cubes formula and multiply by that. Have to know how to remember how to factor perfect cubes or differences of cubes from your polynomials unit. Do all of that algebra to cancel things out. And now we're able to get it very quickly. Now, the derivative of a constant is equal to 0. This is easy to see graphically because if I graph a constant, it's a horizontal line. Any tangent you put anywhere on a horizontal line will also be horizontal. And what's the slope of a horizontal line? It's 0. Okay? If you wanted to use the power rule to prove the derivative of a constant is 0, check this out. Is that the same thing? All right, good luck. X to the 0 is 1. So this would be the same thing. Then what does my power rule say? Put the 0 in front. Well, 0 times 5 will be 0 times 5 times x to the minus 1. Well, that brackets a bit low. Obviously, that's going to be 0. So you could use the power rule to prove the derivative of a constant is 0. You could also just use a graph. if the derivative was 5x to the 4, what do you think the original equation was? Y equals x to the power up. But there's more than one right answer to this one. Because the derivative of a constant is 0, you could have also had x to the 5 plus. Maddie, do you feel like there's been a number that's been neglected in high school math? Or do you have a favorite number? 4. We could have plus 4 here. And it would still have that same derivative. Because we're going to find out that when you're adding and subtracting, you can do the derivative of the first one on its own, which would give you 5x with 4. And then you could do the derivative of the second one on its own, and the derivative of 4 is 0. So we could have any number, right? It could be plus 7, plus 13, plus 4, right? If you're feeling like the number 23 hasn't shown up enough in math class, it's a prime number, never comes up in factoring, I need it to be more representative, you can now represent it a little bit. Oh, so this is where, yeah, oh, there's some practice things at the bottom. Yeah, we'll leave this for tomorrow or next